Hello everyone, I'm Xiugang. Let's compile first. We forgot to compile earlier, and there might be another mistake somewhere here. Here we can clearly see that the mistake is in our header file. There must be a circular dependency here because it keeps including itself. Here we can see that these two bodies have errors. The reason for the error here is that we slowly typed the semicolon. I think at this stage, we're at now. Everyone should be fine because we've actually already written about 20 to 30,000 lines of code. These common issues, you should be able to troubleshoot on your own. And then over here, we'll start it off for everyone first. Let's take a look at what our current node looks like. Everyone write a number. We have already started it here. Then we are in the observation bar graph. Just find this node. We won't worry about this for now. Let's just look at this node first. Simple should be it. Okay, you see our node, it actually looks like this. Right now this node is completely fine. But there is one problem, that is currently it has no functionality at all. Except for this rendering capability, it actually does nothing inside. And if you try to call it, maybe there will still be problems. Because our blueprint node, that method actually didn't write it properly. Okay, let's just take a look. Okay, let's change the name here. Let's not make it so long. If it's written too long, it looks a bit uncomfortable. Okay, then next, we'll just go ahead and write this method. So let's write this method first. This method actually just takes our uObject. Let it slip out such a method. So first of all, we definitely need to slip out a uObject. Okay, let's write this part. Okay, this part will definitely give such a pointer. Then this pointer, this object, we just need to seek it. Okay, with that done, next we'll store the related APPID, key, and all the data inside it. Here we have no choice but to copy this data. Let's delete these prefix marks. This way our code looks more elegant. Because if it's too long, it's also quite unpleasant to look at. This part is the most prone to errors. Because training, its K and C are fast. Sometimes you will adjust it for coordination. You must not coordinate it. If you coordinate it, it won't be able to handle it here. That's okay. Then in this way, actually, there is a piece of data. The recruit data we need to use. The info data is ready. Then, next we activate it. After activating it, then we are here. Actually, here, the blueprint will remove this. After it leaks this object out, it will call this object the activity method of this instance object, then we execute it at the next level. We definitely need to include logging here. We include the logging. If we include logging like this, we mainly focus on this. This log named. Okay, good. If we include it this way, we might as well also write down some of our commonly used one. First of all, let's include this for everyone. DLTs convert. We are working on this hierarchy. A header file needed for this conversion. Then what is this thing? This is something we talked about earlier. If you can't click into it now, just ignore it. Hey, is it? What actually is it? It's actually what we use for encoding conversion because we might encounter some encoding issues. So we included it. Then regarding doing one step after doing one step, we need to create the header file for this step. Then we use basics4. So this place is basics4. This is something we use often. So it should be listed here. It's very commonly used. And this is a version control because when writing it earlier, there were actually version issue, right? We are currently on 5.44. That's the release version. So no problem. As for the rest, it should be fine. Okay, let's go back. After going back, then right away here, we type in this word because this is still quite important. If you don't log it, you simply won't know which information was sent and which information was not sent. This place is the mark, what we are executing. And here we need to write a URL. This URL is actually very simple. Just take the tag URL in front of this part and copy it over. We don't add the. You can also add the S. It doesn't matter. Okay, then here we need to prepare a method. to perform this URL concatenation. We'll talk about the concatenation later. Because this concatenation is quite troublesome, it would be best if we had a general purpose method here. Let's think about this method. Actually, let's write it here. For example, in this link base. Okay, as for this general purpose method, I'll call one over here. That's it. Then let's change this name. Use this name for it. This method must be static. Then here we definitely need to pass in this secret. Our encryption must have this URL. And then this key code. Must and strike APPID is not needed. Adjib is used as content data placed in the post body rather than concatenated on the URL. Then here we prepare two things to receive them. One is this output URL and the other is this protocol code. As for the rest, just ignore it for now. Okay, actually we can just leave this as it is. So at this point, we don't have this method yet. It actually passes these three in, right? After passing them in, it outputs these two things. So let's write this method here. Okay, let's paste it. And we don't really need this because it's a post. Let's just hardcode it. Okay, we won't do anything here for now. Because this method, the encryption, needs to use this set of things above. It's still a bit complicated. Let's first write out the framework for everyone. Okay, at this point, we need to include its header file. Okay, good. After including it, let's assume this alter y. We have already finished spelling it. This particle system is not needed for now. Don't worry about it. Good. So what should we do next? Next, we need to prepare the request data properly. First, as a content instance, because this content instance, so this is actually our layer. And at this point, we need to define the data we are requesting. That is what we defined. With Squire info, we need to set the values inside it. So let's first take a look. Its parameters are roughly divided into three parts. We can see we mainly need to, so actually we need to do this work, and this work is actually quite simple. But it might be the first time we write something this complex. So I'll still guide you through it step by step. First, we need to define the header, this UObject. Let's first define the header as a use and fit array. Okay, let's define this position again. Okay, we don't need to expose this to Blueprint because this is something we assemble ourselves. I'll just have you copy it over. We'll draw it. Then we put these comment triangles in front. This knowledge is a bit too much. It will affect everyone's reading. Okay, we don't need this score either. Okay, then let's change the name. It should be X into simple, chung fei, silent. Okay, so that should be fine. Let me explain. This is this. The first one is the APPID. Then it's essentially, we will later from our SECX copy this APPID onto it. And at the same time, this is Studios because it transmits everything at once. So it just transmits 3 like this. Because when we talk about QuickSpec later, it has a 012 because the data in between is transmitted in multiple batches. Then there is something that starts and ends the same way. Then we will write the second parameter next. Obviously, the second parameter is an object. It wraps another object. Then it wraps another object again. So writing this becomes quite troublesome. Then we need to write this object first. We'll bend it over here. This object mainly has these parameters. These parameters are encoding. That is UTF-8 coding, then text, compression, format, and JSON. Then we put it over here. Okay, let's delete all the comments. This comment is too long. Then let's change this name. As for this name, let me take a look. It's a bit long. Okay. Actually, when I wrote it backwards. But here, for everyone's convenience, we'll write it forwards. And sometimes for the sake of this action, because this struct is really long and cumbersome, sometimes for convenience we'll make a micro view of it. Make a micro view so we can collapse it because this struct is really too long. Good. Okay, good. We can collapse this thing now. And this thing, it's actually our parameter. Parameter this parameter. Then we need to copy this part below it over. So let's directly copy one of these, overwrite this, then hide this, then flip it over. Then after writing this, next we write this structure. It is also an object. There are also two parameters. One is video, one is this thing. Then we copy it over. Okay. Let's just delete the comments. Then we put this struct here because it's just these two parameters. And pay attention. This name is in lowercase. You know Gogang likes to capitalize in a fancy way. But the reason it's lowercase here is because it has to match this part here. Otherwise it won't match. It won't be recognized. So it's lowercase here. Okay. So after matching it like this layer is essentially done. Then on the outer layer, we still need to wrap a parameter called parameter. So we wrap another layer around it. Then we need to delete the friend cast here. This was before. It was previously to ensure. It was to restrict others from using it. So we need to add friend. Okay, let's narrow the spacing a bit to make it easier for everyone to see. Okay, then next we go to set the parameter. And it actually comes down as a struct directly. Then we copy this over. So this middle layer, the parameter corresponds to this. This object wraps an object, and this object wraps a string plus an object. Then such a nesting is written. This way we write the load data. When writing load data, we actually first define such a load because it also has many layers of nesting. If you don't collapse it, it will be very troublesome to look at later. Okay. Then after we finish collapsing, we first look at what its bottom layer is. It is actually object to object. So the bottom layer is the object input 1. That is an input image. Then we bring it over. We delete the comments. What does this parameter mean? Actually, you can tell just by looking at it. There's nothing much to 一则笔写 pattern type. Yeah, okay. Then here, delete this. Then this is our first layer of data. The names here, we might need to change. Let's replace them all with this. Let's check if all the previous names have been updated, because it might have been directly copied from the game. Obviously, the names here haven't been updated. Okay, delete it. Alright, let's change the names here. After making this change, we need to change this here. Okay, only then it won't have any issue. Let's see, this name should be placed here. The name above goes here. Okay, if there are no issues, next we'll write the payload, then just wrap another layer outside the payload. Let's delete this. This name needs to be changed here. Okay, so at this point, we've actually finished writing this struct. Next, we just need to put this struct here. We can take a look. Just put the 3 structs we wrote earlier here. We can just snap it over here. Okay, previously, why did we set it to protect it before? It's because this thing is built internally by me. And since we don't need to be that strict in the tutorial, making it public should be fine. Let's fix the prefix. Okay, so the final serialized JSON string from these three structs should look like this. There's no issue here. We should compile it here. Compile it. Let's make sure it compiles successfully. Good compilation is fine too. So the requested data is defined. Next, let's walk through the entire request process. As for the request process, we need to perform some negative processing on this data. So first, what do we need to do? Actually, we definitely need to take this thing, get a hold of this thing, and we must attach the ID of its first parameter. There is an APPID in its header. Now we set it equal to the ID passed in from outside. Then we need to prepare a method here, which is to perform a simple transcoding based on the IPPID format passed in. It is actually our payload. In the payload, there is an input, and inside it, there is an encoding. But this, what is this parameter? This parameter is this. It is called. It is a. That is to say, it is not selectable. That is to say, you'd better write it down. It's encoding format. Then we need to prepare a method here. Prepare a method to convert this previous enumeration for us. Here you. Didn't we have an enumeration before? Right? This enumeration is it. This enumeration. This initial enumeration. We folded all of these. This enumeration. Then extract a parameter from it. It hasn't been implemented yet. Let's implement it now. This parameter is relatively simple. Here we directly use. We didn't use the reflection method to get this enumeration because I'm worried it might cause some other issues. We simply use the switch here. Keep it simple. After using this switch, we can then take the unused ones and fold them away. This will be used later. So here we can call this method convent image type 2 star. So this part here is it. This image type. We convert this image type into a strt. Complete a simple copy here. Okay. Next, we need to process the base64 data of our image. So here, we write image base64 str. Note the encryption method for image. We can directly use FBS asks for encode. Then we directly give it a binary data. That will encrypt it here. Okay, you can see there are some methods here, right? And they can be called in different ways. You can, if we use it in UE5 ourselves, actually, using F3 is the most convenient. But once a situation arises, that is, sometimes the encrypted data encoding is a bit different, so we'd better encrypt the binary data. That is more reasonable and appropriate than this place. It might also have some modes. That is, there are some other modes. Then we'll just ignore them. Just use it like this. Then after this side is encrypted, we need to check the size. Actually, the maximum size of this file is 4 megabytes. So that's 4 times 10. 24 times 10. Then after we encrypt it, we check whether the encrypted result meets the requirements. If the encrypted subtitle is empty, that is, if you pass an empty one, it will still be empty after encryption. And the space it occupies, if it exceeds 4 megabytes, then we need to call this method, that is, the size of this image is incorrect. So we need to let the user know about this situation. Then the user will be aware of it. Well, actually, we could also print a log here, but we didn't write it here. Anyway, you have already conveyed the information to the user here. You failed. Okay, now we release the resources here. Remember to release the resources. Then we can end it in WTL. And if there are no issues, actually we can do it here. Let's move it over here. We take this recruit info and move it over here. Okay, good. So actually here you'll notice this part is not written very elegantly, because here actually, if this really has 4 megabytes, you're constantly copying this data here, copying it back and forth, and then copying it again over here. You could use some C++ programming techniques to reduce the number of times this copying occurs, or move the memory, things like move semantics. We won't emphasize here, because the impact is not significant. actually. Okay. Then at this point, we convert our required info into our content string. So actually putting it here. Putting it here is also fine. Good. Convert it into this content string. Finally, we take this content string and send it out together with our URL. So this raw HTTP, it's relatively simple, just like what we wrote earlier. We first create an HTTP here. Then we bind its method. It's obviously bound to our class method. Then we set the URL. Then we give it the post. Its access type and the data we pass is JSON. So we set a header. Content type is JSON. Then we set content and stream. Right. Then we just pass the JSON in. Then we just need to help it process it at the end. Okay, basically, this completes the sending phase for everyone. Okay, alright, at this point, let's take this recall info. It corresponds to this phase. We'll send this phase over to everyone. We haven't covered encryption yet. We'll cover encryption in the next lesson, because if you don't encrypt it, you actually won't be able to access it. Also, the interface. It will prompt you with a level 1 service error. Okay, we'll stop here for this lesson. Thank you all.